This video is about parallelograms on the coordinate plane.
So it's important to start by reminding you of these three formulas that you're going to use pretty much any time you're doing geometry on the coordinate plane. Distance formula lets you determine how long a segment is. The midpoint formula lets you find the point that's right in the middle between two other points on the coordinate plane. And the slope formula lets you find the slope of any line or segment that's drawn on the coordinate plane. Why would slope ever matter in the context of a shape like a parallelogram? Slope lets you determine if lines are parallel, because then they would have the same slope, or if lines are perpendicular, because then they would have opposite reciprocal slopes. So the when to use it guide on the right side of this slide is going to be really helpful. You just have to pick out what proof you want to use for the question at hand. So for example, you might be asked to prove that something is a square. It's drawn on the coordinate plane, it looks like a square. To prove that it is using numbers, you have to think about what does a square mean. A square means four sides are equal. So you might want to show, using the distance formula, that you have four congruent sides. You'd have to do the distance formula 4 times and prove that all 4 sides come out the same. But that's not enough for a square, because just proving sides congruent means you have a rhombus. A square also has 4 90-degree angles at each vertex. So for that, to show that 90-degree angles exist on the coordinate plane, you need to show that the lines are perpendicular to each other. So you're going to want to come down to the slope formula and prove that you have sides that are perpendicular. So you'll do the slope formula 4 times and look for those opposite reciprocals so you can see that you have 90-degree angles. So this is a good cheat sheet to have written down and consult it when you're doing a geometry question on the coordinate plane. For example, is triangle ABC scalene, isosceles, or equilateral? To redefine those words, scalene, 3 different side lengths. Isosceles, 2 side lengths the same. Equilateral triangles have all 3 side lengths the same. We're talking about side lengths, so we want to use distance formula. Establish where your coordinates are at each vertex. And then you'll use these to find 3 distances and determine what kind of a triangle you have. So we're going to use the distance formula for AB. And if it's not a whole number, we'll just leave it as a simplified radical, because we're really just trying to compare it to the other side. So then it comes out to the square root of 25, which is a whole number 5. Okay, so that's AB. We need to do this for BC. And 4 minus 0 squared. And we have 4 minus 7 squared. I'm a little loose with the order here. I know that it doesn't really matter if I do the x first in the parentheses or the y first, because in the end I'm just adding the 2 values together. This one also comes out to the square root of 25. So now I know I at least have 2 sides that are the same. And I'm guessing that the third side is different. It looks different. I can tell that the points are a little bit further away from each other. But I'm going to prove it using my distance formula for AC. Subtract the x's and square the result. Subtract the y's and square the result. So 49 plus 1. This is the square root of 50, which is, we'll do it as a simplified radical just to get in the practice of it. Split 50 into 25 and 2. The square root of 25 is 5. And the root 2 stays. So I've got 2 side lengths the same and 1 different. So the answer to this question is that it's an isosceles triangle. So we've used some coordinate geometry to prove something about a polygon on the coordinate plane. Let's get into quadrilaterals. We've been learning lots of properties of quadrilaterals lately. This question is asking if ABCD is a rhombus, and it asks you to explain. So you're going to have to show some work to back up your answer. You might say, oh, it looks like a rhombus, sure. But you need to show work to prove that it is, and then explain your work. We've got a few options for proving that something is a rhombus. The definition of rhombus is that it has 4 sides of equal length, and that it is a parallelogram. So that actually has to come first. If this thing is not a parallelogram, then it is most certainly not a rhombus, because a rhombus must be a parallelogram first. And that means it has parallel sides that are opposite from one another. How am I going to prove that a side like AB is parallel to DC? Well, I'm going to have to use slope to prove that they're parallel. So the slope of AB is y2. I guess I'll use the point b for y2. So y2 minus y1 over x2 minus x1. This ends up being 4 over 2, which is 2. And the slope for DC, I'm going to label these AB and DC, and this is slope calculations. So for DC, we're going to use 5 minus 1 over 4 minus 2, also 4 over 2. So I have one pair of opposite sides that are parallel. I'm going to do the slope of BC as well. 5 minus 4 over 4 minus 0. You do get very good at these as you do more and more of them very quickly. And then 1 minus 0 over 2 minus negative 2 also comes out to 1/4. Okay, so I know for certain that I have a parallelogram. I've proven it. I have two pairs of opposite sides that have the same slopes as one another. So they're two pairs of parallel sides. And then more specifically, I know that rhombuses have to have 4 lengths that are all the same for the sides. So I'm going to use the distance formula to find the length of each of these segments. So AB, length of it is going to be, subtract the x's, square them, plus subtract the y's, and square them. This ends up being the square root of 4 plus 16, which is the square root of 20. I'm going to do BC next because I feel pretty confident that it's not going to come out the same, but I want to prove it to myself with the numbers. So I've got 4 squared, which is 16, and then 1 squared, which is going to be 1. And sure enough, this did not come out to the square root of 20. So I've established at this point that I don't have enough information to prove that it's a rhombus. Actually, I do have enough information to prove that it's not a rhombus because I don't have 4 congruent sides. I did prove that it's a parallelogram, and sometimes the question's going to ask you to classify the figure that you're looking at as with the most specific name you could possibly give it. The most specific name we can give this figure is just that it's a parallelogram. At least we proved that, which is why I went through the whole process of doing this. So you might think, couldn't you just do distance here to show that it is not a rhombus? And yes, the answer to that is yes. As soon as you've proven that the two sides aren't the same length, you know this thing is not a rhombus. So the explanation is not a rhombus. Sides are different lengths. But I wanted to show that whole process of finding the slopes as well, in case the question asks you, like maybe a follow-up question. So if it's not a rhombus, what is it? Then you're going to want to be able to classify it using the slopes to show that it's a parallelogram. The figure shown here is a kite. That's another type of quadrilateral we'll learn about in a future section. This is asking us the most precise classification. So there's an example of that question that I just previewed. So the most precise classification that we can give for the quadrilateral that's formed by connecting the midpoints of a kite. So the midpoints on this kite, I can actually see them on the coordinate plane, so I don't need to calculate them, though you may want to if the figure was slightly more tilted or something where you couldn't easily see the midpoints. I can see the midpoints here, so I don't need to use the midpoint formula. I'm going to connect the midpoints, and I've formed what looks to me like a rectangle. I need to use some coordinate geometry to prove that I have a rectangle. Now, rectangles are parallelograms that have opposite sides parallel, opposite sides congruent, and 4 90-degree angles. So I think I'm going to just skip right to the heart of it and see if I have 4 90-degree angles. To determine if I have 4 90-degree angles, I want to find some slopes. I'm going to call it ABCD, just so we can be talking about it in terms of sides. The slope of AB, because it's a horizontal line, the slope of AB is just 0. I don't need to use the coordinates to show that the slope of that line is 0. If you did use them, you would get 0 because the y minus the y would give you 0 on the top of the fraction. And the slope of DC is also 0 because that's a horizontal line. The slope of AD is undefined because it's a vertical line. The slope of BC is undefined because it's a vertical line. By showing that, I've proven that I've got, I guess, opposite reciprocal slopes. 0 and undefined are opposite reciprocal slopes. So I've got a bunch of opposite reciprocal slopes, thus proving that I have perpendicular lines, thus proving that I have 4 90-degree angles in the corners. And for the sake of this, that's sufficient to show that it's a rectangle. Rectangles don't have 4 sides that are all the same length or anything else going on about the sides, other than the fact that it's a parallelogram. I use slopes to prove that it's a parallelogram also, so like the 0 and the 0 show that I have parallel sides across from each other, and the undefined and the undefined show that I have parallel sides across from each other. I know it's a parallelogram, I know it has 4 90-degree angles, therefore I know it's a rectangle. It's the most specific classification. There is a more specific type of rectangle that it could have been, which would be a square. And it would be a square if all 4 sides were the same length, but I can tell just by looking at these, because these are horizontal and vertical lines that I can count the length of, that these are not 4 equal sides, and therefore this thing is not a square. And that is all.